And we have welcome for this virtual IoT webinar. We typically do those on Wednesdays or Thursdays. Well, we had a last minute change, so we're talking to you on a Friday and just before Eclipse Con. Actually, we're gonna. Many of us are going to be headed to Eclipse Con next week, and I'm actually very much looking forward to the IoT Summit there. And yeah, today we've invited David Woodard from Eurotech and from the Eclipse Kura project to tell us all about what Kura does. Kura is, as you can see, a gateway framework built for IoT. So David, without further ado, why don't you get started? And a quick reminder to all of you guys, if you have questions, don't wait until the end of David's presentation. Please ask them either using the virtual IoT hashtag on Twitter, or you can use meetup.com if that's more convenient for you. You can comment there on the event page, or I think Google Hangouts also allows you to ask questions in the Q&A. So yeah, without further ado, David, you already have 20 people watching you. We were wondering earlier. So good luck for the presentation.
Okay, thank you, Benjamin. Thank you for allowing me to be here and to speak about Kura. Should be very exciting. Also, thank you for allowing me to change the date to Friday. Sorry for the last minute change. Okay, so a bit about me before we get started. As Benjamin said, I work for Eurotech. I am a software engineer supporting the ESF framework and also our Everywhere Cloud platform. I'm also the project lead for the Eclipse Kura project, which is why we're here today. So let's get started. So being a Eurotech employee, we're a IoT enabling company. So we work with a lot of customers. We hear a lot of stories about IoT and what people are trying to do in IoT. And oftentimes the first story we hear is a very simple solution, somewhat like what's on this slide. They think we have to measure some data, we have to get that data through the cloud, and we have to act on that data in some way. Maybe that's a website, maybe that's a smartphone application, but it's very linear and it's very, very concrete in what their plans are. And this is very easy, right? If this was the solution, we probably wouldn't need to be talking about an entire framework because you could implement this in-house relatively quickly. But what ultimately happens is you go from a solution like this or a problem like this to more of a space that looks more like this, right? So it's not ultimately one sensor. It's a lot of data you're trying to measure, or a lot of actuators or sensors you're trying to act on. And even more complex than that is, maybe you can handle the sensor part, but what about your transport layer? How are you connecting to your cloud service? Is it Ethernet? Is it Wi-Fi? Is it satellite, cellular? There's so many options. And if you're talking satellite and cellular, you also have to deal with failover conditions, like what happens when your connection goes down or not available. All these things need to be thought through in advance. And if we go one step further, how are you consuming this data? It's often not just a simple website or data store. It's often all these things. You may have mobile phone apps, email, notifications, web apps. It's all those things, and they all have to play together. You can't just usually pick one and focus on that. You have to be flexible in how you allow your team and also potentially downstream customers to interact with data that you're collecting from your devices. Collecting the data is great, but you need to do something with that data in most cases. Okay, so the architecture that we see or seeing emerging is one that we believe in, and we're seeing it more and more in other companies and other solution providers, is this sort of, put the complexity in containers, try to not solve all problems at once, and look at solving the problems in a logical, orderly fashion. So for the business application side, like you need some cloud platform. There's a lot of cloud platforms out there, but there's some commonality. You need data storage, you need device management, and you need some cloud-to-cloud integration, because as IoT grows, all of these companies are going to need to play together in some fashion, right? So cloud-to-cloud, APIs, like all this stuff, very, very, very important. And this makes some of the complexities of business logic, data storage, device management a little less scary. And on the downstream side, and where we're focusing today, is on this sort of highlighted section of the gateway, the sort of like device that's sitting on the edge of your sensor network, or the network of actuators or widgets that you're trying to interact with. On this side, this is where you want to handle the connectivity to the cloud. This is where you want to handle your interaction with your actual measurement devices, or whatever your devices might be. And this is where we'll spend our time today, specifically with Eclipse Kura. Okay, so an IoT gateway, what is it? What is it supposed to do? As I mentioned, the idea here from an architecture standpoint is this is a physical device sitting on the edge of your data collection telemetry space. So you can think of this as being what your temperature sensor or your humidity sensor or your water level monitor would connect to, right? And what it needs to do is provide that sensor connectivity, provide that I/O access. So it's easy to plug your temperature sensor or your gyroscope, whatever it is, have those connections available to all these different devices in the field. The gateway also needs to manage the connection to the cloud, and this is an incredibly important piece, because as you scale, as you grow, connectivity is going to change. So you're going to need wireless, you're going to need Wi-Fi. Moreover, in many cases, you'll need things like the firewalls. You'll need VPN. All these things come into play. And you also need to consider things like online and offline modes. Like if you're dealing cellular and you're dealing satellite, there are going to be times where you're going to be offline, and how do you handle that? Application management. So, it's great to write an application and deploy it in the field, but if you're deploying in a location that's not easily accessible, if you're thinking like the gas and the oil pipeline sitting out in the middle of nowhere, sensor measurement that's going on like deep within a building's like subsystems, these aren't things that you can get to easily. Moreover, it can be very expensive to get there. Sending out technicians, all these things cost money. So the ability to remotely manage these applications, start them, stop them, update them, becomes really, really important. And again, talking IoT connectivity, we're talking MQTT, we're talking co-op. You have to manage these connections, because these are both great protocols, but they really specify the communication piece. They don't really specify what happens when you're offline. So doing things like buffering data, connection retries, these all become very, very important when you're building out your architecture solution. So hopefully everybody on the line agrees that I'm exactly right and this is all great. So what's the big deal? Why is it hard? These are sort of the three main areas that we've identified. It's fragmentation, it's complexity, and it's lock-in. And these are the three things that come up again and again and make it very difficult to get a solution from the planning stage to like an actual deliverable product. So if we start looking at these individually, you can sort of put them in containers for each section. So like with fragmentation, just looking at the sensor side, we're seeing just a wealth of different options. It's Zigbee, Z-Wave, CAN bus, Modbus, BLE, 6LoWPAN. All these things are really gaining a lot of traction, getting a lot of popularity, and we hear about them all the time. And the reality is they're all good for certain purposes, right? So you want to be able to be flexible enough that you're not limited to just one of these, right? But sometimes this fragmentation can become problematic when you're trying to figure out how do I interface with all of these different devices. And the protocols listed here are just the ones that are publicly known. There are also, a bunch of proprietary protocols in the field. If we start looking at the device, we run across multiple operating systems, compilers, different programming language, different CPU architectures. Very, very common problems that I think we're all used to. And network, I think we're gonna beat this one to death today. It's that connectivity piece is so important, and especially as we're seeing more and more cellular and satellite-based connections. And and standards and communication protocols. Again, there are a bunch out there, and all have their place in IoT. I'm not here to advocate for any one protocol over another, but the key is, can you be flexible enough to move to either meet the needs of your company or meet the needs of your customer or your user. And complexity, right? So this is, again, going through each of these buckets. We look at things on the sensor side, where we're looking at, when you're dealing with sensors, things are often like very timing dependent. OS support for dealing with these sensors can be very varied if you're going between, Linux or Windows. Like getting the correct low-level drivers to talk to these sensors, and the timing to do that is not trivial. Again, on the controller side, again, talking about multiple architectures, multiple operating systems, you have to worry about cross-compiling and managing your application across all these different systems. Testing, debug becomes very difficult. Network, again, bandwidth considerations, cost-based routing, like how much, what is your budget for network and for communication? And as we move up the stack, you start getting into concerns about security, authentication. All these things incredibly important. A lot of our customers have customers themselves, and what we hear all the time is, it's so hard to convince some of these larger companies that, oh, okay, we're just going to go put a product on your public network, and we hope that that's okay. Like, that's a thing you need to consider, and you need to have a good story about why your security solution is okay for their environment. Lock-in. So this is something that we've seen in the past. It comes up time and time again, and I think hopefully as IoT develops and grows, and we're all buying more into the open source stories and solutions, maybe we'll start seeing less of this, but it's still out there, right? It's the notion of, if you buy my gateway, you also have to use my cloud and my protocol, and all this really limits the growth of IoT. So this is a thing that we're really hoping to, by investing in open source and talking about open source, that we can avoid some of these issues. And we'll talk about this more and later in the presentation, but avoiding this lock-in is very, very important. Okay, so let's start getting into the solution. So I've kind of outlined the problem. Again, hopefully I've got a lot of heads nodding in the crowd. That's the intent anyway. I can tell you from our standpoint, we see these problems a lot. So the solution. So how do we overcome this? Well, we implement a few things, and the idea here being is, like we've seen many times in our profession, is abstraction, right? You've got to abstract that complexity. And the way we have chosen to do this is, we've moving left to right. We said, okay, well, if we look at the gateway, by itself, you're looking at hardware, and you're looking at likely some Linux operating system. And on top of that is where you're going to have to put all of your code to do your sensor management, to do your connectivity. That's where your code is going to live. Well, let's get rid of some of that complexity right off the top by using Java. Java, love it, hate it. The one thing it is very good at is being OS and architecture independent, right? So you can, the whole write code once and use it anywhere methodology, while not 100% foolproof, it does work and has been proven. And if you look at the numbers of Java developers in the world and companies using Java, it's still very, very, very high. And if you look at what we're seeing from Oracle and these other Java enabling companies, they're also very committed to IoT. They're looking at ways in Java 8 and Java 9. You're seeing a lot more commitment to getting the JVM running even more efficiently on these small form factor devices. So it's an easy. We see it as an easy win solution when you're talking about these IoT gateways. Now we also take this next step. We say, okay, well, Java's great for removing some of those dependencies, with CPU architectures and operating systems. But what about the modularity? Like, how do you deal with these applications that may be running in various places throughout the world, and we want to avoid having technicians to go out to change things. Like, how do we address that? Well, we took the approach of using OSGi. OSGi is part of an alliance. It's a complete specification for running Java code in a modularized fashion. And what this allows us to do, so for those not familiar with OSGi, is it's essentially a container that puts your Java source code into what they call bundles, right? And these bundles are independent pieces of your application that can be controlled and versioned independently. So the common examples of this are your application's up and running. You have a specific piece of your code that you need to update. You can do that without bringing down the whole application, right? You just go in and say, update this one bundle, and the rest of your application runs as normal, right? So if you look at this framework, and your code that you're writing has become, that huge white block on the left has now become that really small white block on the right. It's running in this container as a single bundle and pretty high up in the stack in the OSGi container. So managing that, your application becomes actually quite simple. Doing remote configuration updates, doing remote version updates becomes, all things considered, fairly trivial. So the big win here that we see is the developer productivity, the time to get something from, oh, we need to do this, to actually having a proof of concept that window becomes a lot smaller, right? You have a lot more bandwidth to actually perform this task. Well, so the previous slide, I think, took care of some of the complexity and some of the fragmentation. It's at least addressing those problems. It doesn't really address the lock-in question, right? So what about the lock-in? And more than just lock-in, what about the other common problems? And again, this is coming from experience. This is things that we hear in the field is, the pressure to add value, the time to doing that is getting smaller and smaller. There's so much pressure to get product out, to get it out quickly, to take existing products in the market and make them IoT enabled. Is that time frame to do that is getting really short. The velocity of which IoT technologies are changing. Like, our field is an exciting one, but it's a hard one to keep up with. I think we all know trying to keep all the protocols and the communication methods straight can be difficult. And our belief and the reason that we have gone down this path is that interoperability absolutely is more important than trying to do like exclusive differentiation. So saying, we have a lot of answers, but if we may not have all the answers, so what's important is that we can be modular and work with other products in the field. And all of these questions, or a lot of these questions, are being answered through open source initiatives. And it's very important to us at Eurotech, and we're seeing, a lot of the partners that we're working with are doing the same thing. And that's how we came to the Eclipse Foundation and the Eclipse IoT Working Group. You'll see a lot of companies in there that you'll recognize, like Eurotech, Sierra Wireless, IBM, all companies committed to the same notion. We're all in here working together, trying to enable the IoT industry, like removing those barriers that's currently or heretofore been, I think, somewhat limiting growth. Okay, so Eclipse Kura. So this is where it comes from, right? So giving you the story, kind of giving you an idea of what the framework, what we see as a solid framework for solving the problem. This is where Eclipse Kura comes from. The code base was donated by Eurotech about 2 years ago, a little over 2 years ago, I guess, where we went to the Eclipse Foundation and said, hey, we think we have a good solution. We've been using it in the commercial space for years, and we would like to donate, portion of this code to start enabling the industry. Like we're tired of seeing the fragmentation. We're tired of customers saying, well, we can't move forward because the overhead is too high. Let's see if we can get over those barriers. So we started the process. We go through all the IP review with Eclipse, and we released the first version of Kura in September of 2014. Since then, we have been really excited about the adoption and the use of Kura. It was, I think, more than we expected, and more important than that, I think, is the continued growth and the continued excitement around it. We've seen contributions from other companies coming in, like from Intel and Red Hat. Just very excited about integrating with Kura, making it part of their systems, like writing adapters and extensions to it to make it work for different scenarios. It's all been very exciting. And here's just some raw numbers, and these are even a bit outdated. I think we're seeing just a large number of downloads of Kura every month. And for me personally, as I said, more than just the initial, hey, that's a lot of downloads, is the continued growth. So I think it's showing that people are using it, and giving us validation that this is something that we can use. This is something that's helping us in the industry. Okay, so if we start, digging into Kura a little bit, and what it does and how it works and how it can help you solve problems, is let's do a block diagram. Like everybody loves block diagrams, right? So, at the bottom of this you have your JVM. Above that you have OSGi, which can be Equinox, Concierge. The container is not important. ESF, or I'm sorry, Kura will work in any of these containers. But when you start looking at Kura itself, you start seeing these sort of like, abstraction blocks, right? This is how we're dealing with the fragmentation. This is how we're dealing with the complexity. We take things like, if you look at the device abstraction, right? We've already done a lot of the work for Serial. We've already done a lot of the work for GPIO and I2C. So if you need to interface with these devices, you have confidence that you can come to Kura, use these services that are available to quickly get your sensors and measurement devices up and running. And you see this repeated throughout the framework, right? So you see this with the basic gateway services, like controlling the clock and the watchdog. Go up a level to the network. We provide a full web UI for doing network management. So for those who do a lot of Linux network management, this is important. Having a UI that you can go to and control your firewall and control your Wi-Fi settings, control your cellular settings. Like this is a very, very powerful thing. Remote management. We have these services running that allow you to implement the remote management in a way that's best for you, right? So that the services are there for you to use, and it's an incredibly important part of how you ultimately roll out your IoT solution, because you have to be able to manage these things remotely, because in most cases, accessing them can be very expensive. Field protocols, the ones that come with Kura, Modbus, CAN bus, but the important thing about the field protocols is we've tried to make it very easy to add ones that you may also need, right? And we're going to talk about contributions later in the presentation, but this is an area that I would like to see grow. I would like to see more of these field protocols come into Kura and being contributed by the community, because the community is what ultimately knows what we need in here, right? I mean, this is what would help drive this portion of the diagram.
David, a quick question for you regarding, architecture-wise. There's a question from Dan. Well, Dan is very impressed by Kura, and we're only halfway through the presentation. And the question is around the support of OSGi and the possible similarities with Apache Sling, which is based on JCR. And well, there are actually two questions. Are there, can both work together? Can you use Kura together with something like Sling? And even further, can you use Kura on other containers than OSGi, like other than Eclipse Equinox?
Sure, great, great questions. Thank you. I'm not familiar with the first product, so my answer right now is I don't know. We're happy to look into it. The thing that I can tell you about how Kura runs is it runs as a single Java process on your system. So it itself is pretty isolated in a JVM. So typically we don't see issues running with other types of frameworks and other types of applications. The only time you get into problems is obviously with like shared resources. So just depending on memory footprints and resources you're trying to access, typically is the only time we see problems. But as a concept, again, Kura is just nothing more than a Java process. So I would guess that it should be okay.
And another quick question, sorry to interrupt, but I think that's the best moment to ask. And the good thing about virtual IoT is that we get questions from all over the world. This one comes from Colombia. So yeah, in terms of requirements, you made it pretty clear that, well, Kura is on top of the JVM, but do you have some experience on integrating or at least interfacing Kura with real-time operating systems like FreeRTOS and stuff like that?
That is a question that comes up from time to time. The biggest issue we've seen right now with those types of systems is the access to a JVM. So what we say as a requirement is that you have to be able to run a Java JVM embedded. If you can do that, then in theory Kura should be fine. We haven't actually seen this in practice yet, but I think it's coming, and we're pretty excited about it. And if we have these opportunities in the field, I would love to hear about them through the community and see if we can work together to address them. The other thing to consider is, Kura is being OSGi, it is modular, so there may be pieces that won't work for like a RTOS type system. So Kura does use certain native libraries to communicate with low-level services on a typical Linux, ARM x86 type of framework that may need to be removed because you just don't necessarily need those in an RTOS system. But I think it's definitely possible. It's just somebody sitting down and solving the problem, is my opinion. And then I think the last question was about the containers. So Kura is not written for a specific OSGi container. It is written against the version, currently is version 3.8 of the OSGi spec. So any container should be fine. We've definitely seen it in Equinox. We've definitely seen it running in Concierge. But I think Carafe or even Process from a commercial support should be just fine.
Okay, cool. And for the JVM, you need the compact 2 profile, right?
You don't have to. So the only JVM requirement still at this point, we're still actually supporting Java 6. So is Java SE embedded is really the only requirement. Past that, you can kind of use the flavor that you want, and it's been proven all the way up through Java 8 and Java 8 profile 2. Yeah. Okay, great, and thank you for the questions. Okay, so moving on. So one thing that we look at, let me back up one slide really quick. So if we sort of zero in on one of these blocks, if we look at the connectivity piece, we use internally in Kura, we use another outstanding Eclipse project called Eclipse Paho. And PAHO is the MQTT client library, or the Java client library provided by PAHO. Yeah. So that's what we use internally for making the client connection for MQTT. It itself is a fantastic library, but Kura often does things to make using those libraries easier. And so if we dive into that one specific use library, we can take a look at what I mean. So anyone on the line could use PAHO directly, but some of the issues that aren't addressed in that methodology are outlined here. So I have it broken down in 3 different services, and these services are ones that you would find in Kura, and you can look at their APIs and see what they're doing. But in short, we have one called the transport service, which manages the actual connectivity credential pieces, right? So what is your broker URL? What is your username? What is your password? What is your client ID? All pretty straightforward, and things you could do directly with PAHO, probably pretty easily. And I'm going to be talking pretty MQTT specific topics here, so hopefully that's okay with everybody on the line. But if we move to the next section, to data services, the thing that PAHO doesn't really address out of the box, and the thing that the MQTT spec doesn't really address out of the box, are things like connectivity and reconnect policies, and what happens if you disconnect. They certainly have things like QoS and retention, and these things are absolutely part of the spec. But we feel they're a bit limited at times when you look at like an actual IoT solution. So things, when you lose your connection, how do you connect? Do you immediately try to reconnect? Do you do it in certain intervals? This can be very important depending on your environment. Message queuing. So when you go offline, what are you doing with all the topics you're trying to publish? So if you think about your gateway, it's likely not running a single application, right? It's likely running multiple applications. It's likely publishing data at different rates. So what do you do with all this stuff? And the thing that Kura provides is a prioritized message queue, right? And that's important for 2 reasons. One is that the queue is present at all. So when you go offline, all your messages are not lost. They're stored and they're ready for when your connection comes back. But also you can put a priority on them. So if you have alert messages, or you have application critical conditions that when your connection comes back, you want to send those out first, that's all manageable within Kura. And this is an incredibly important concept. If we go up another level to the cloud services, another thing about MQTT is it doesn't, is agnostic to the payload, right? It doesn't care what the payload is. It only describes the connectivity between brokers and clients, which I think is brilliant. I think that's the way that it should be. Leave the data model for the application or higher. And that's what we're doing here. Is we're saying if you use cloud services, we've come up with a data model that makes a lot of sense for the majority of IoT applications. It's based on just a simple metric value model, but then also leaves the payload, an agnostic payload available as well. So you can do metrics, and you can also do just random binary data if that's what you choose to do. It also does an important topic called topic partitioning, and this is something that a lot of customers don't, or a lot of users, don't think about when they're first creating their applications. Is if I do have 1 or 2 or 10 applications running on my gateway, how am I sending those messages? Like, what do my topics look like? Well, the cloud service takes care of this for you. It by default separates all of your applications into their own sort of MQTT topic namespace, if you will. So, upstream, as you're ingesting all this information, you can do so in some logical fashion. And again, this is a important thing to think of early on that some people miss. Compression. So if we're talking cellular, we're talking GSM type connections. Bytes matter, right? So you want your transmission to be as efficient as possible. So we use Google protobufs as a way to efficiently serialize the data before sending them out of the device. If you start thinking about device management or application management, knowing what's happening is important. So that's where we get into these next things, like birth certificates and death certificates and applications certificates. So notifications that your device is online or offline, or that some new application has come online. These are all ways that you can, all things that you can utilize further upstream to manage what's happening on your device and what's happening in your sensor network. And lastly, for this piece is, we've implemented this thing that allows a REST-like communication model over MQTT. So you can do things like get and put and post to specified resources within Kura. So this, provides a nice management layer for a lot of people who are familiar with that methodology of working with APIs. And again, this is all mimicked by doing this all over MQTT. So the general idea here is showing is that we've taken something that's a very powerful product in itself in Eclipse Paho, but we've added a lot of the very IoT specific best practices that we've seen over years of doing this and problems that we've seen people trying to solve over and over again. So we put these in these services and make them available for use within Kura. Okay, so I would imagine that I'm talking to a few developers on the line. So out of the box, what can you expect? I think that the most important thing is you don't actually have to buy any hardware to go try out Kura. Like, just download it. It's fully integrated with the Eclipse IDE. You import the workspace, and you can, for those running Mac or Linux, there's actually a really nice built-in emulator that lets you run Kura on your local machine. This is really great for just getting started, running some of the introductory Hello World type bundles and applications to get you started and get your mind thinking about how this can really be useful for your problem. The next piece is, once you are ready to move to a device, maybe it's a Raspberry Pi, maybe it is a commercial product, is we actually have the ability to, from the Eclipse IDE, to do one-click deployment of your solution. So you can connect directly to your device, and from the Eclipse IDE, send your application directly over. It also has the notion of remote debug, right? So you can have your application running on your remote device, and if you enable this this feature, you can actually do the breakpoints and the monitoring of your code from your PC, from your Eclipse IDE. Again, this is I use this frequently. This is an important thing when you are writing a new application. And then the cloud managed piece, and as I said, all these solutions typically need some sort of remote management, and you will get this as well through the remote OSGi management via MQTT and these web-based consoles. So this is a very important piece as well. Okay, so I'm going to shift gears a little bit now. So this was sort of like the overview of Kura, and sort of stating the problem and the problem that we believe Kura solves. Gonna sort of address the question I get a lot, and I think Benjamin gets this question a lot as well. Is this is all great, but so what? Like how do people use this? Like, what really is going on with Kura? Like, how are people doing this in the field? Maybe some of this will register with people on the line. They'll see something like, yep, this is exactly the problem that I'm trying to solve. So I'm going to walk through a couple of use cases, and I'm going to start, and I'm going to try to do this from like everything from like a maker sort of mindset all the way up through like commercial products. And hopefully some of this will be useful for someone. Okay, so the first thing that I would encourage anybody who's interested in using Kura and interested in really seeing some of its flexibility is to go check out the greenhouse demo. This is something that Benjamin Kabe actually put together, gosh, over a year ago now, I think, maybe longer. So it's been around a while, but it's a fantastic use case for what Kura can do. And the reason is that it sort of exercises a lot of the pieces that we've been discussing. I mean, you can map the diagram here back to one of my very first diagrams of the complexity of IoT, right? You've got multiple sensors connected over an I2C bus. You've got a GPIO LED. You've got the connectivity piece, and then you also have a business logic WebSocket consuming data. Right, so this whole thing is put together for you very nicely. All the source code is available. You can the hardware cost is pretty minimal. I think this whole setup is including the Raspberry Pi is around $50 $50 US. So very, very low cost to get in there and see what Kura can really do. And I think these slides will be available, so the URL for getting there is on this slide. But also, if you just Google Eclipse greenhouse demo, it'll be the first Google hit to come up usually. But this is very, very maker oriented, but a really great introductory to the technology. If we take a step further, we start getting into things that this are still somewhat maker oriented, but also getting into a bit more complexity. So every year Eclipse hosts a IoT challenge, which invites people from the community to come and make a solution, make something happen. And the only caveat is they have to use open source IoT solutions. So some of the things that come out of this are really fantastic. I'm just going to highlight two here that I thought were particularly interesting. And maybe just get people thinking about what you can do with Kura. The first one here is they called it IoT into space, where their initiative was actually to send a Raspberry Pi up. I can't remember the height now, but up essentially space, so very high, and communicate back down with the measurements from whatever altitude they're at, back down to another Raspberry Pi on the ground, and then consume that data using some cloud endpoint. But the cool part to me was that the piece going into space was actually running the Kura. So, Eclipse Kura in space. It was very exciting to me, right? And you can kind of see the stack that they proposed here and the different pieces they were going to utilize. I think this is still an ongoing project, but you can Google it and see how these guys are doing. But I thought very, very interesting. I thought. The next one, and sorry for the simple slide. This is actually a really cool project. That I couldn't really find a good way to put together what it's doing, so I'll just kind of give you an overview. This one is called IoT Vaidia, I believe is how you say it. It's an IoT medic, and this is one of my favorite because of just the originality of this, right? So this is someone trying to solve a real world problem, right? So the idea being is that as a patient, you could be somewhere in the middle of the country, in India or anywhere in the world where maybe it's hard to get to a doctor. So the idea is they would create these really low cost devices that had different, medical measuring features on them. So heart rate or whatever else it may be, hooked into the Raspberry Pi. And then through a very simple, touchscreen interface, they could enter their medical information and have that uploaded to some web service that some remote doctor could access, and then maybe give some sort of feedback on the condition of the patient. So I thought this was a brilliant use of technology, and one of those IoT spaces that to really prove that IoT can be anywhere, right? But they did this with Kura running on the Raspberry Pi and providing those connections between all the sensors that they're measuring and managing that cloud piece. Okay, so to move from this sort of, this one is hard to call a maker community, but to move for these sort of like development community to a more commercial space, I'm going to do some selfless promotion of our own company is Eurotech. So how is Eurotech using Kura, right? I mean, we donated it, but how are we still using it? And the answer is absolutely. We use Kura in the core of our product called ESF, which is on every gateway that we ship. It all has ESF, which by definition means it's also running Kura. And one of the biggest wins that we see is we go to people and say, hey, if you were developing or you're prototyping with open hardware, Raspberry Pis, BeagleBones, Intel Edisons, please do that. We think that's great because when you're ready to go to commercial, none of your work is lost. Like it's a direct translation between what you're doing and what we're doing, right? And this is a good story that people like to hear, and has been very, very good for us. And the reason that this topic is sometimes hard to talk about is we have all our NDAs with our customers, so sometimes it's hard to release information on what our customers are doing. But if we do take one example, we can look at Ariston. So Ariston's a very large company in Europe, and in this case, what they were focused on is the boilers or the water heaters that they put in their customers' homes, right? And as I was mentioning earlier, it's very expensive for them to send their technicians to a home to do maintenance or to do troubleshooting. So they use this sort of idea where they put our gateways on the boilers, and we're using our cloud platform mixed with their business logic to do this remote management and sort of preventative troubleshooting to try to cut down on costs for their technicians. So been very successful. A lot of press release around this. So I would encourage you to go out and Google this if you're interested. Solaire. So Solaire, very similar to Eurotech. They have a very good gateway product to try to get people to market quickly. Also using Kura, and this is similar to Eurotech. They're using Kura at the core of their product because it is open source, because they know that it is compatible with a lot of other products. OnSense. So OnSense, their specialty is interfacing with PDU devices. So this is much more industrial. They try to make all of the PDU behavior exposed, through a gateway, through a Kura, back up to remote management endpoints. So they can do, control and monitoring of these PDU devices without physically being close. And this is very important in the industrial space. They've been very successful using Kura and have been a big proponent of Kura pretty much from the beginning. And I rushed through these a little bit because we're getting short on time, but feel free to look at the slides and send the questions if you have them. As Benjamin said, sending them to Twitter is also great, using the virtual IoT hashtag. Okay, so shifting gears again. So what's coming? So kind of showed you what Kura is, and hopefully there are people on the line who have used Kura and are somewhat familiar with it. So for those specifically, this is sort of what we have coming in the very near future. One is we're updating the web UI. So previously the license wasn't exactly aligned with the Eclipse public license. So we have solved that with a new UI that will be completely license compatible. And the biggest benefit to this is it will simplify the build of Kura, and also the distribution. So if you go to download Kura right now, you'll see like a bunch of downloads. It's a bit confusing. All that will go away. So it'll just be one download for your platform, and you'll be good to go. It also allows us to move, so we use GWT internally for development of our web app. And it allows us to move to the newest version of GWT, which helps with some security vulnerabilities. It will also be based on Bootstrap. So right now the Kura UI is not super impressive on a mobile device, but being based on Bootstrap, the new version will be responsive to mobile browsers. Also, we have something that we're going to call Kura Wires coming, and this is something based on an OSGi spec called Wire Admin service. And this is like a message-oriented design pattern where you have emitters and consumers of data. So this will at least easily allow you to connect various Kura services together. And that of itself is a great thing, but we're also going to try to do a JavaScript type configuration of these services. So it's not all just banging away at code. You can actually say, well, I already have these services. Why can't I just go to the UI and just tie them together? Sort of Node-RED type of diagram-based configuration. Apache Camel. So we have we're in the process right now of bringing Apache Camel into Kura, for doing message routing, and this has a lot of possibilities, and we really want to see some activity around this from the community, and much more. And I think the message I want to stress, whenever I talk about Kura, is that the developers of Kura are using it every single day. Like, we use it in our commercial products. It's been around for years and years and years. This is not something that I just do in my spare time in the garage, right? This is a real product. It's been around for a long time, and it's something that it is in our best interest and the best interest of our partners to keep developing and keep making it better. And to turn the table.
Sorry, there was a question earlier. I got some echo. Not sure. So the question was, you mentioned the users of Kura, like Ariston and stuff. In terms of contributions, what are the companies besides Eurotech contributing on the project?
Oh, sorry. Sorry, you were breaking up a bit. So one of the questions I heard was, who else is contributing to Kura? Right now, we have seen Intel and Red Hat have been big contributors, but I believe there are more coming soon. We're getting a lot of interest from other partners in the field. And I didn't catch the other question. It seemed like maybe it was around Ariston, maybe?
No, there wasn't. So
okay. Okay, good. And I believe I also heard a question about hopefully contributing in general, because it's my last slide. This is the thing that we want to sort of push for, and especially in the next year, the thing that I'm going to try to do, my due diligence in is getting more support from the community, getting more contribution from the community, because I feel this is really a way that Kura can grow in a very, very positive direction. So what I've outlined here is, things that we immediately know are good places for getting contribution. So things like, getting support for Ubuntu Snappy, doing plugins and packages. These two things are huge. So from the Eclipse standpoint, like creating plugins that allow the creation of bundles for Kura to be easier. For Kura specifically, if you have a good application, or you have a good utility or something for Kura, let's put that in a nice, clean package that somebody can just take and install into their framework and use it. Other areas, user management and the web UI. This is something that people ask about a lot. Right now the user management is pretty simple, but a lot of people have said, hey, that should really be a bit more role-based management. So we definitely see that as an area that we could expand on. Support for co-op and lightweight M2M. These are very, very popular protocols, and we would love to have a nice solution for easily plugging this into Kura. We actually have some prototypes of this started, so this will be a great place for somebody to pick up and run with. Kura on Android. This is a big one, right? I think this would be next level of cool right here, is to get Kura running on an Android device. So if anybody has any interest with that, or has specialty with Android, we would love to hear from you. And I provided the link that kind of gives an overview of what's involved in contributing. It's pretty simple. I think you just have to sign one agreement, and then you're ready to go. And then we're happy to work with you. And that's pretty much it for me. Again, you are important. We do need your help to make Kura better going forward. And that's it for me. So I'm happy to, whatever time we have left over, take any questions, or I guess I'll just turn it back to you, Benjamin.
Thanks, Dave. And hopefully the echo is gone. Yeah, it looks like it. Good. So yeah, as Dave said, if you have any last-minute questions, now is the time to ask them. In the meantime, I will take a few seconds of your time to remind you guys that the Eclipse Foundation, together with IEEE and the Agile European project, is running a survey to understand better the trends in IoT development. So I think you should all have received an email last week or so with a link to the survey, and I realized that I'm probably not sharing the URL right now. So yeah, it's on surveymonkey.com/r/eclipse-IoT. Otherwise, you will find the link in the forum board on meetup.com. We would really appreciate if you guys would take just 5 minutes to basically tell us what you are doing with IoT. I'm sure that among the 800 participants in this meetup, lots of you guys are actually doing some real IoT stuff, right? So yeah, just wrapping up and trying to figure out whether we have some pending questions, and it doesn't look like we do. I would really like to thank you all for attending it. I think it was an unexpected day today, and for some people in Europe, it's actually getting late in the Friday, but still we probably broke a record actually of the number of live attendees. So I would also really appreciate if you guys would take some time to give us a review on meetup.com to review the group, and it's also a great way for you to let us know what you would like to see in the future, less technical, more technical, more embedded, less embedded, etc. As you will see, we already have a few webinars lined up for later in March and April, but if you have other ideas, please let us know. And I still don't see any questions, so you will be able to comment on the YouTube video for those of you who are watching the replay. And as Dave mentioned, we will also make the slides public. So I think, Dave, you will, if you can upload them on SlideShare, that will be just great. And I will add the link to the slides on Meetup and YouTube for everyone to get access to all the links that you shared for the greenhouse tutorial and for the customer stories, etc. So thanks again, David. Thanks all for attending, and we'll be in touch soon. I don't quite remember when's the next meetup, but we'll be in touch soon. Bye-bye. Take care. Thanks, Dave.
Thank you. Bye.